Hi everyone. Yep, so I'm just going to go through the models and the workflows section of DAFNI, which we'll go through the process of uploading a model and then using that in a workflow. So I'll head over to the modeling section to get started. So this is a list of all of the models that we've got available on the platform at the minute. A lot of them are this. I'm logged in as an admin at the minute, so I can sort of see everything that people are playing around with. So you'll see a lot of hello worlds and stuff like that. Many of these models come from the pilot program that Brian alluded to earlier. So we uploaded those in the early days, and that was mainly just the DAFNI team doing the uploading and stuff like that. But more recently, we've had much more engagement from the community, and we added features like model upload, which allow users to upload their own models fairly easily. And so many of the models that come on these days are actually user provided, user uploaded, which is obviously really exciting for us because it means that we've built a system that people can actually interact with, upload and share models, which is really cool. So how do you add a model on DAFNI? You go across to add a model up here, and then there's all this documentation you can then go away and read through. So we've sort of documented the process of uploading the model fairly extensively, and the process is fairly technical, but hopefully it would allow someone that is used to building models to be able to do the model upload. And it's important to note that once that bit is out of the way in terms of the putting the model together, uploading it onto DAFNI, they can then share that with any other user on DAFNI, and they wouldn't have to go through this process of containerizing the model and putting it onto DAFNI. So there are sort of two things that you need to put a model onto DAFNI. One is, I'll show you. One is this model definition file. So this should be fairly simple to understand. It sort of has sections within it for the description, the summary of the model, the title, stuff that you'd expect to see. And then you can sort of expose these parameters, and we'll see how these parameters then get exposed to the user of the model at runtime. So you can specify these things that you might want to change. I probably should have said this is the COVID-19 COVID sim model that came out of Imperial. And I've sort of just nicked that from their GitHub page and then containerized it and put it onto DAFNI. So it's quite simple for someone who knows what they're doing to take an existing model and put it onto DAFNI. So these are all the parameters that we can change, and you will see these in a second. The second thing that you need, which is perhaps more technical, and I won't go into too much detail about it, but is a Docker file. So Docker allows you to basically encapsulate a load of code into a container, push it off somewhere else, and then unpack it and run it in the exact same way that you do on your local machine. So it makes sure that whatever we're running on DAFNI is the exact same as whatever you're running on your local machine. And so within this Docker file, we essentially install a load of stuff that we need to run our model. I clone it from the GitHub page here, install a load of extra stuff, and then at the end just run it through. So I won't go into too much detail about that, as I say. So once you've got those two files, you can sort of confirm that you've done all this stuff. You can then browse to the files on your local machine. I've actually zipped up the model image because it's a smaller upload then. So that's the Docker image, and that is the model definition file. Put those in and hit upload, and then it goes and uploads that. It wouldn't take too long to do that, but I think probably not worth waiting around for it because I've already done it. So yeah, this is one that I uploaded earlier, and you can see that all of the metadata that I put into that file that I showed has then been put onto this page in a nice format so that a user could read through that quite easily. You can see all the stuff that we can change within the model, and we can get an idea of what comes out as well in terms of output files, which is really good. And something that we've added recently is model versioning. So you can actually upload multiple versions of the same model, which is obviously really useful for people who are constantly changing their code. And what you can then do is, if you're uploading a new model version, which is like bleeding edge, you can not make that the default version so that new users coming to run your model will still use sort of the stable version of that, which is really nice. So once we've got our model, obviously we want to do something with it, and to do something with it, we have to use the workflow system. So this is kind of like the meat of the modeling service, if you like, and it's where you come to actually run the models. So I can see all the models that people are currently running. There's currently some workflow executions going down the bottom, but we can make a new one. So we'll just call this COVID, and this is just metadata about the workflow itself. So we won't worry too much about that at the minute. So this is our workflow builder system, which has 4 different step types that you can choose from, and then you can chain these step types together to form your ultimate workflow, essentially. The first step type that we've got that I won't use today is the iterator step type, and this is actually something we're actively working on improving because we're aware that it's sort of fairly limited at the minute. But what you can do in this step is you can set up a Monte Carlo style simulation to iterate over a certain parameter type and vary it between a given minimum and maximum value. So you can imagine with a COVID-19 model, you might want to vary the R number, for example, between a 1 and 2 to see how that then affects the results. And so you could then do some kind of sensitivity analysis based on that. So that's what the iterator step is for, but we're working on adding stuff like while loops and more complex iteration types. So that's sort of on the way soon. The next thing is probably the most important step type, which is the actual model itself. So we will add one of these. So call the step name COVID. We'll then go into select a model and select our top one. And then down the bottom, the parameters section is then populated with the defaults of our parameter set that we've specified in our metadata. So you can see that how we turned what was quite a complex thing into quite a simple thing. So a sort of non-technical user could come along, add a model step, and then easily have these parameters exposed to them, explained to them, and then choose which they want to change to run their simulation. So I could change the R number, how many people are complying with the quarantine restrictions, stuff like that. And there's also lots of different countries to choose from there as well. Down the bottom, as Bethan mentioned, you could also input data set into a model. So that's something we've added fairly recently. We understand that a lot of models are actually based off like census data or UKCP data. And so you can add a data slot into your model and say, we want to use this data set from the catalog by default. But then we allow the user to change that at runtime. So obviously the new census is going ahead now. If you've got a model which uses the 2011 census data, you could then change the data slot at runtime to use the new census data whenever it gets published in 10 years time or whatever. This doesn't have any data slots associated with it, but you can see how that would be useful. So we can create that step. And then the final 2 step types we've got are publisher and visualization. And this is just to get information out of our model once it's finished running. I should probably say actually, yeah, so you could, the whole idea was DAFNI was to combine these different models. So you could have multiple models in here, multiple model step types that chain together to form some kind of complex simulation. So you can imagine if we go back to census data, that might have implications on how the coronavirus affects the UK. So you might want to feed some census modeling into a coronavirus model to get a more accurate end result. So you could easily chain models together in here. And that's something we've done with the NISMod project, which might get talked about today. So the publisher step simply takes the outputs of your model and puts it into the data catalog that Bethan was showing you. So if I switch this split, we can get the exact same metadata form that Bethan just filled out. So I won't bother going through that again. And the other type of output that we can do is a visualization. So we're currently working on adding more visualization types to DAFNI. At the minute, the only option is Jupyter Notebooks, which I'll show you in a second. But obviously the idea of this is to do some post-processing on your data and produce some nice graphs from it, and then share those with other DAFNI users, which is the ultimate goal. Again, you do have to fill out the metadata because the data does still go into the data catalog. But the only additional thing that you have to do is choose your visualization type and create that step. So I could do that, but I've already created one earlier and run it. So this takes about half an hour to run on DAFNI. On my local machine, I couldn't even run this simulation for the UK because it uses too much memory. So my machine was running out of memory. So it kind of shows you the other side of DAFNI, which is that it enables people who don't have the hardware at home to be able to run models like this, which are actually quite demanding. And obviously, you get some kind of speed up element there as well because of the quality of the hardware that we've got behind the scenes. So as this model workflow ran through, you would have seen the tick change to a clock, which then changes to a tick once the workflow is finished. So this visualization step is all done. And so if we click on that, we then get this option to visualize at the bottom. And if we click that, we'll be taken to our visualization instance, which in this case is a Jupyter notebook. One thing we're working on improving is obviously with a Jupyter notebook, you still have to write some code to be able to do the post-processing of your data and to draw these graphs, which is obviously a limitation because we want the platform to be as accessible as we can make it to non-technical users. So we're currently working on adding a drag and drop style visualization, which will allow people to literally drag and drop stuff from their data set onto graphs, etc. So they can create these things much more easily. As it stands, Jupyter notebooks are the way that we create visualizations, which for those of you not familiar, Jupyter notebook will essentially give you an environment where you can write some code in Python or R, which extracts data from the data set, and you can then draw plots from that. So this again is something I stole from the GitHub page of the Imperial people that made this model. These are the output data sets that have actually come out of the model. They're all in Excel format, I think. So they're not particularly readable in this interface, but we can use this nice script to extract data from them, run it through and draw some nice graphs of our results. And then we could obviously use those in reports, download them, and use it to kind of figure out what kind of parameters we want to change for the next run through and the next scenario. And that's it from me.